All right, so in this video, we're going to go through another comparison, side-by-side analysis using the pandas and polars libraries. So in this video, we are actually going to be using a data set that is open sourced by a bike sharing company. So I'm just going to pull up real quick. Let me get a new incognito tab. And in particular, we're going to be using this data from Bluebikes. So if I do a search for Bluebikes Boston, let me say not now, and then let me make that a little more specific and say data. All right. So if I go to Bluebikes, apparently they are a bike sharing company that is located in Boston, and you can see here that you can download their trip history data. And they have data going all the way back, it seems, to 2015. So in particular, the data that we are going to be using is going to be from this essentially June of 2024 all the way back to July of 2023. So if you want to download those individual files, you definitely are more than welcome to. So if I were to click any one of those, it's going to try to bring down a compressed folder. So they've uploaded these as essentially archive, zip archives. Also, if you go to github.com and you were to search user:"Freemanalytics" and you go to repositories, so we're going to be working in this pandas polars comparison. I've got a Bluebikes folder. There's going to be a completed version of the notebook that we're going to kind of be working through today. And then I also have got a zip files directory with the files that we are going to be using. So if you just want to go to the Git repo, pull that down, or the GitHub repository and pull that down, you should be able to get that either way. But again, we're going from this 2024-06, which is for June of 2024, all the way back to July of 2023. All right, so I have this demo folder on my desktop. And in it, I have a folder called zip files. And then there's all of the Bluebikes data files. And again, these are all, they give them to you as zip archive. So if I just click on one, you can see there's a CSV file that's in there. And then they have essentially a Mac OS, it looks like some Mac OS X folder in there. So not necessarily sure what that is, but what we're going to do, we're not going to go through and uncompress all of these. We're going to do that in code. So that will actually kind of demonstrate how we can use the zip file library that's in the standard library of Python. So we're going to automate that process. All right. All right, so just another disclaimer. So there is a completed notebook at that GitHub repository that I was showing previously. I'm not going to try to emulate that, perfectly, right? So I am definitely using it. I've got that pulled up and I will be looking over it and kind of to guide me along as I do this. But by all means, I'm not going to try to, sit here and take the time to make sure those things are exactly equivalent. More or less going to use it as a guide to kind of go through and maybe talk through a little bit of some things a little bit more detail, and then just know that notebook is up there, and it is, even though it's not going to be a one-for-one matchup of what we do in the video. All the questions are going to be answered, but the code, I might have some extra spaces or something else, but the essence of what we cover will definitely be in there. All right, so I am going to activate. I have an environment on my machine called primary. And just to show you, if I do a conda list, and in particular, what I'm going to be looking for here is going to be polars. So we got polars. I'm on that version 1.0.0. And then also pandas, we're going to be using that. I'm on version 2.2.2. Okay. So I'm going to clear and then launch Jupyter Lab. All right, so I'm going to bring that window over to the screen. All right, so you can see I'm on the desktop in that demo folder. Those are those zip files. So these are all of our Bluebikes data. So that is what we are going to be working with. So the way that you should, set up the structure is you're going to have a notebook, and I'm just going to rename this notebook real quick. I'm just going to call it Bluebikes. All right. So I now have a notebook called Bluebikes, and then within the same directory as that notebook, there's a subfolder called zip files, and inside of that are all of those zip archives that you can download from that Bluebikes data trip history website. All right, so let's go ahead. I'm gonna zoom in just a little bit. I don't want to zoom in too much on this one. All right, so let's import some libraries that we're going to use. So we're going to use two libraries from the standard, two that are part of the standard library. We're going to import pathlib, and we are going to import zip file. And then we are going to import, let's just go ahead and get matplotlib, pyplot, it's PLT. I'm going to import matplotlib.ticker is mticker. We'll import pandas, it's PD. Import polars, it's PL. I'm going to import seaborn, it's SNS. And then we're going to import, we need to do a from tqdm.auto, import tqdm. All right, so again, I'm using Anaconda distribution, so I have a Conda environment with all of these packages installed, so matplotlib, pandas, polars, seaborn, and tqdm. And I am just going to print out, because the two libraries that are the most important in this video are going to be pandas and polars. So I'm going to just do a pd dunder version equals, and then a pl dunder version. Again, we're on pandas 2.2.2. If your version's a little bit different, that's probably going to be okay. A lot of the things that we're using, especially from pandas, are going to be just kind of like core functionality that has, existed for a while. But on polars, you may want to go ahead and do this upgrade. So I purposefully put these videos out when the 1.0 release was recently released, right? So this should be, this is the stable release, so it's out of a 0 version, so I would expect a lot of the things that we see to be quite stable. But again, things will, in both of these libraries may change in the future, but hopefully you can kind of, get a sense of like, okay, what should I be looking for as I'm, maybe taking a pandas analysis and trying to port that over to polars. All right, so the first thing that we really want to, get a grasp of is working with or loading in those zip data files. All right, so I'm making me a quick little note. All right, and we're going to use pathlib and this zip file. So first off, let's create essentially a pathlib object that is just pointing to that zip files directory. So I'm going to say zip files directory. And that's going to be pathlib.path. And that directory that we have on our machine is called zip files. And then what I'm going to do is make a list of zip file paths. And I'm going to do that by taking that directory, doing a .glob, and getting everything that ends with .zip. And I'm just going to go ahead and consume that. That will return a generator. So I'm going to consume that generator, store it in a list. Right, so we're going to have our zip file paths right here. All right. And what I'm going to do is I want to just demonstrate something really quick. So I'm going to say zip file path is equal to our zip file paths, in particular the first one. So again, on my machine, that's coming back to be the 2023.07. Yours, it might be a little bit different, right? Because I think I'm just going to run this a few times. Looks like it's actually sorting that, which is interesting. But, it might not always point to the same one, because I do believe, at least previously, glob might come back in a random fashion, and that's okay. The key thing I want to show is how we can, what's the structure of these files and how we can use that zip file library to work with it, right, and read that into pandas and polars. We'll have to need to go through and uncompress each one of those files and do all of that, which would take time. All right, so what I'm going to do is I'm going to create a variable called czip, And I'm going to say that zip file module, it has a class called a zip file, and I'm going to set that to my zip file path. All right. So now this czip is this zip file object, and it's in read mode. And when you create one of these zip file objects, it has a method called nameList, right? And you'll notice that this is essentially going to be like if I were to pull up that file on disk, demo zip files, it's this one right here. So if I double click this, it says, oh, well, there's this directory in here called _ Mac OS X. And then we got this tripdata.csv. So basically it's saying, okay, well, you've got one CSV file, and then you've got a subdirectory Mac OS X, and then within that is some ._CSV file. All right, so we can use this name list, and one thing to kind of note, let me print what zip file path is right now. So the current directory that I'm in, or I'm looking at, is 2023-07-bluebikes-tripdata, and notice that they named the CSV the same thing, right? So within that directory, there's a CSV file that's named the same thing, okay? All right, so what we can essentially do then, since we know the zip file path, right, so that's where we're looking, I can get the name of that. Right, it just gives me the name of that without the directory, right? So it's just what's the name of this file object, and that returns a string. So I can do a replace .zip with .csv, and that's going to match, right? So this string matches the name of that file in that zip directory. All right, so we're going to use that, right? So this is going to be my CSV name, right? Okay. Now, so we've got this czip object, and what we can actually do is, so we can actually read that, right? We can say, oh, well, you know, the czip is essentially an object pointing, you know, to a read mode of that zip file path, and I could, you know, read that name. I'm just going to bring in a lot of data right here. Probably too much. Probably didn't want to do that to the screen. Let's see if I can get that to stop. Let's just make sure I'm not killing my memory. Yeah, that was probably not the best choice of things to do. Right? Yeah, so it's reading that data. So it can grab that content back, right? So notice we can use that read method as bringing it back in as bytes, or you could open that file path. So you've got a czip.read and you got a czip.open on that name. Let me just do a quick restart to clear all of that out. All right, now interestingly, you can use these two methods with pandas and polars to read in that data directly into a data frame. So for pandas, it's actually different for both. So I can do a pd.readcsv, and then for pandas, what you need to do is provide that open method. All right, so that's reading that data right in as a CSV file. And if you wanted to do that for polars, I'm just going to put this right underneath, just comment this out. We can do a pl read CSV, and then instead of doing, you know, czip.open, we need to do a czip.read, and it's going to bring that in. All right, so we can get those in with polars and pandas. All right. All right, so we're going to put all of this stuff together right real quick. So what I'm going to do is I'm going to create two objects. I'm going to create one called data PD, and that's going to be a PD data frame empty. And then I'm going to do data PL, which is going to be a PL.dataFrame. It's going to be an empty data frame. We've got our directories right here. All right. And what we'll do is we're going to say for zip file path in those file paths. So we're going to iterate over each one of them. And instead of just opening it like we did right here, I'm going to instead use a context manager. So I'm going to say with zip file, that module, dot. So I'm going to create one of those things, one of those objects, those zip file objects. I'm going to pass it my zip file path, and I'm going to say as czip. All right. Let me clear this out. Okay. So this is essentially opening up a readable, so I'm essentially opening or creating a zip file object pointing to that, whatever the current file path is in read mode, saving that as a variable czip. And this nice thing about this context manager is it's going to make sure everything's nice and closed up for me at the end. And I'll say CSV name is equal to whatever the CSV, the zip file path is, replacing .zip with CSV. I'm going to use this code down here. All right. I'm going to create a temp pandas data frame and then a temp polars data frame. And then in both cases, what I'm going to do is, so for pandas, I'm going to say, well, okay, well, temp data PD is equal to pd.concat whatever's currently in data PD plus whatever's in this new temp PD file. And then I'm going to do the same thing with data PL. So we have a polars concat, and I need to make sure I'm concatenating my polars data frames. All right. Polars data frames do not have an index, but what pandas is going to do is going to read in each one of those temp PD files. They'll have their index, and it's just going to pop them together. So what will end up happening is you'll end up having duplicate index values, because the first file you read in will have an index label 0, the next one you will, and you'll end up with those duplicates. So what I'm going to do at the very end for my pandas data is do a data PD dot reset index, and I'm going to say drop equals true. All right, and then we will finally print data, do an F string, so we'll do data PD dot shape equals, just to check and make sure these things are exactly the same, and then data PL. Now, I'm going to probably end up restarting running all a few times. So instead of reading all 12 files for now, we're just going to read in 2. Okay. And let's go ahead and wrap this piece right here, this list, in sorted, so that hopefully all of our, if you're using the same data files that I am, the 2 that you use will be the 2 that I use. And this will just help us as we're kind of developing and doing our analysis. Everything will be a little bit quicker, and then we'll come back at the very end. We'll run it with all of our files. All right, and let me do one last thing. Let me put this in TQVM just to get us a little bit of a progress bar. All right, so it's going through, it's doing our loading, and we end up with data PD has 853,215 rows, and so does data PL. So looks like we've got our zip data loaded, and we can just check if I were to bump that up to 3. All right, so in this case we've got 1.27 million rows. All right, so I'm just going to leave it right there for now. It's only taken 3 seconds. It's not too bad. And let's just take a real quick look at this data PD. Let's just look at the head of that. All right, so again, this is ride sharing. So this is from Bluebikes in Boston, and each row of this data set corresponds to a ride or a trip on one of their bikes. So you see we have this ride ID, which is a unique identifier for the ride. We have a rideable type. So is it a dock bike? There's also a classic bike and an electric bike. And then we have some timestamps for when the ride started or when the trip started, when it ended, the start station, end station, some of those type of information. We do have some latitude, longitude. And then we have this last column they call member casual, which designates the type of rider. So it can either be a member, so apparently there's some type of, maybe they have some subscription service where people can subscribe and maybe they get reduced rates on bikes, or it can be a casual rider, maybe someone that's visiting the city and just has, it's taking one of the bikes out for a spin. And that's one thing we're going to do a lot of analysis around this to see if there's differences in behavior between members and casual riders. All right, so I'm just going to get these columns, print those out. I'm actually going to do it from the polars data frame because it actually gives me back a list, which is a little bit easier to read. All right, so this is going to be our list of column names. And one thing that we're also going to need at some point, we're going to be looking at a lot of differences in, how these members or these casual riders ride. And one thing that we're going to do is we're going to look at how they vary over the days of the week. So I'm going to go ahead and create this little dictionary object called day order that we will need to use at some point. So, I'm just going to label, and this is done purposefully because as we're going to see, polars, you can use polars. If you give it a date, it can give you back the weekday, and it gives you that back as an integer, where 1 is equal to Monday and 7 is equal to Sunday. So we're going to go ahead and define a dictionary that says, hey, 1 maps to Monday, 2 maps to Tuesday, and so forth. And then we're also going to use this to sort the days of the week in the correct order. So I'm just going to go ahead and define that mapper. Say 6, Saturday, 7 is equal to Sunday. Great. All right, so here's going to be the questions that we are going to answer. All right, so let's write these out. So questions, and then we will go down and we're going to have a question 1. And this is going to be, how does weekday ridership vary by member type? So I'm using that member type to kind of refer to that column that was saying, are they a member or are they a casual rider? And let me just copy this down. All right, so question 2. So Q2, how does time of day ridership vary? All right, question 3. And let's say, how does ridership vary over the year by member type? Okay. And then finally, question 4. We'll say, how does ride time vary by member type and bike type? All right, so those are going to be our questions that we're going to be looking at. And that bike type, just a refresher, that was in this rideable type column, that member casual thing, or that column that designates whether it's a member or a casual rider was in this member _ casual column. All right, so let's go ahead and get started with our first question. So we are going to start now with our first question. All right, so what I'm going to do is copy this question down. All right, so we're going to be working on Q1. All right, and we are going to look at this with both pandas and polars. So I'm going to make a markdown cell, and I'm going to say this is going to be our pandas implementation. All right, so we're going to start off with pandas. All right, so the first thing, what we're looking at here, we want to know, how does weekday ridership vary by member type. So, if we look at days of the week, do we see that, certain days are, there's more riders of a particular type, either members or casual. All right. And one thing that we're going to do throughout this is we're going to be kind of picky about just, keeping the columns that we need at each step. So what I'm going to do is I'm going to define columns to keep. All right. And to answer this question, we're going to want to know the unique ride ID, whether or not they're a member casual, and we need to know the started at. So we're going to use the started at time to kind of indicate the timing throughout. So we're looking at when do rides start. So we're going to get this ride ID. We're going to get started at, and then we're going to get that member casual column. All right. And we've got data PD. All right. So what we're going to do is I'm going to create a new object called weekday ridership. And what I'm going to do is I'm going to take data PD. I'm going to get the columns that we want to keep. And I'm actually going to just copy that. All right. So in this case, whenever I'm filtering it, I'm essentially filtering this data frame to just include those columns. I like to make a copy of it so I can kind of make sure that I'm not altering the original object. All right, so we've got this weekday ridership, and what we need to do, the interesting thing is if we were to do .info, right now this started at column is an object, so it's representing that as a string, right? So we need to kind of work with, pandas here to see if we cannot get that into some type of a date time, right? So let's just go ahead and do that. And again, I think I'm going to do this just a little bit differently than is in that notebook on GitHub. Both ways will give you the same result. But all I'm going to do is I'm going to say, okay, well, take the value in that column and let me see if I can use PD's toDateTime function to coerce that into a datetime object. So what pandas will do is if you give it a column, it will go through and try to figure out, well, can I interpret this, is this a year, month, day? Can I figure out the format that it's written in? And then I can return to you a datetime object that captures that data. So now we got no errors. If I do weekday ridership.info, all right, we can actually see that now we've got a datetime, right, which is nice. All right. So in pandas, when we have datetime columns, we have access to some datetime methods via the DT accessor. All right. And if I were to wrap this in a dir and run that call, we can see what methods are available through that. And one that is called day name. All right. So it turns out for this first question, pandas is really, really nice and convenient. So I can do this dt.dayname. That's a method, and I can get back the day of week. All right, so I am going to create that, put that in a new column called start day name. Perfect. All right. So now we've got a data frame that looks like this, and we wanted to figure out how does weekly or weekday ridership vary by member type. So what we want to do is figure out, well, how many unique ride IDs are there by this column, this member casual, and this start date name. So to do that, we'll do a group by. So I want to group on all combinations of that member casual column and this start day name column. And then I'll do a .ag, and I'm going to say unique rides. I'm going to take what's in that ride ID column, and I'll do it in unique. All right, that looks good. So we're grouping by those different types and those rides. What we're going to do is, the way that we want to do this, we want to visualize. So I want to get this to a point where I have maybe the days in the index, like have a new data frame with the days are in the index, and then I have a column for both casual and member types. And then I have some value that's capturing their unique rides, or essentially I want to figure out, what's the proportion of all the rides taken by those, different types. And then I'm going to essentially express that as a proportion on each of those days of the weeks. So when we do this group by, what it's doing is returning a data frame. This member casual and start day name, those are actually our index. Right? So it's returning a data frame, but it's giving us back a multi-index. All right. Well, don't really want to work with a multi-index, so I'm just going to reset the index, pull those back in as columns. Okay. And then I'm going to do a pivot, and I'm going to say, well, let's put in the index. So reset index, that returned a data frame. Data frames have a pivot method. So I want to pivot this where I have start day name as the index. And the columns of this pivoted data frame will be whatever in that member casual. And then the values will be whatever is in that unique rides column. All right, so that seems to be looking pretty good. So I'm going to say this is going, I'm going to overwrite our weekday ridership here. All right, so let's see what that's looking like now. All right, so that looks pretty good. And now what I actually want to do is I want to divide each one of these by essentially the sum. So I want to figure out, okay, well, yeah, so casual, we see 53,000 rides. Well, what is that as a percent of all the rides taken by casual members, or as a proportion? All right, it's a little bit odd. In pandas, it's, you might think this is, we could go through and maybe get a series and do some division. It gets a little bit messy. So actually the way to do this, pandas data frames have a divide method. And the way that I remember it, right, it's always, so if I look in here, you have to tell it, okay, other, right? So it's a sequence or a series that you want to do the division on, and then it has an axis. It says, okay, well, whether to compare by the index or columns. Honestly, it gets to me a little bit confusing. So the way that I like to think about it is this, right? So when I do this divide, what I'm wanting to do is I'm wanting to take, like, for example, casual, I want to sum all the values in that column, right? So basically what I'm wanting to do is take that data frame, weekday ridership, and then do a sum across axis 0, right? So down the columns. And then we've got to tell it that axis to compare on, right? So this axis, and by default it's columns. And you can provide, axis 0 or 1. But what I find is what you want to do is if you're summing or doing some type of computation across one axis, you want to specify the other axis for the argument to divide. So in this case, we're summing across axis 0. So I'm going to say axis 1 is what I want to do the division across. All right, that looks reasonable. And what should be the case, if this is correct, is if we were to sum down that column for casual and down that column for member, we would get 1. So if I say sum, axis 0, it's just a litmus test to make sure that, hey, all of those proportions sum up to 1. All right, so now we've got that weekday ridership object. And we do need to do this in a different call because we're computing weekday ridership up here, that initial look at that data frame, and then we need to use it here, so we can't chain this method right on. But in this case, what we end up with is a pandas data frame. We've got 2 columns of proportions. So we can now use something like a pandas.plot to visualize this, right? And what it would do is it will take each one of those columns and plot them against the values in the index. Now, one thing that you note is the index is essentially sorted in alphabetical order, but this is not day of the week order. So at the very end of this, I'm going to say, okay, well, I want to do a .loc, and I'm going to use these dictionary values, Monday, Tuesday through Sunday. So I'm going to say, okay, well, give me back that data frame in the order of the values of that dictionary. So now Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. All right. So let's make this plot look a little bit better. So I'm going to do big AX plt.subplots. It'll be 1, 1, big size equals, let's do 6 by 3. We might have to change that. Let me zoom it back just a hair. I hope that's still, let me keep it in, move that back. All right, and then I'm going to do weekday ridership plot. Let's change that to a bar plot. Let's give it some edge color of K to help that really kind of stick out. I want to put it on that pandas plot on the axis we've got. I'm going to take the spines on the right side and the top side, make those where they're not visible. Let's just take a look at where we are, see if there's anything else we want to do. All right, so we can definitely, let's do a few additional things. So first thing, I want to move this legend over, right? It kind of overlaps. So what I can do is say, well, give me back the legend, and then I can specify a B box to anchor. I'm going to say 1, 1. And what that should do is put that legend in the upper right outside. So if you think about the figure as being a width of 1 and a height of 1, we're basically saying, okay, well, where do we want to anchor the top left of that bounding box or top left of that legend? So I'm going to say, we'll move it all the way to the far right. So 1 on the width, 1 on the height. And that should move it outside. All right. I want to change this from essentially this proportions to a %. So the way that we can do that is AX Y axis. And I want to set the major formatter. And I'm going to use mticker, have a % formatter. And the maximum value that can take is 1.0. So now we should get that as percentages. Let's go ahead and let's kill the X label. So we'll do an AX.set X label. That should go away. And let's rotate those ticks a little bit. So we'll do an AX.tick params. Which axis? I just want to do the X axis. So I'll say axis equals X. And there is a label rotation argument, and we'll do that at 30. All right, let's give ourselves a Y label or vertical axis label. So AX.set Y label. Say ride percentage. All right, and let's give ourselves a title. So let's set the title. And we're going to say ride percentage by day of week and rider type. All right, so it's a decent looking plot, right? We cleaned some things up. And if we look at this, we definitely see there's a pattern, right? So if we think about the casual members, definitely the majority, or there is at least a significant increase in ridership among casual riders on the weekend. Versus in members, they tend to be higher during the week, in particular Tuesday through Thursday. So we're already starting to learn something which probably matches our intuition, which is a good thing. That means that, okay, the data is behaving as expected. It's kind of a good little litmus test. And what is that? Well, probably your members are people that live in the city. So this is data for Boston. So they probably live there and they're using this service to commute to work maybe. So they're more active during the week. And then the casual riders, they might be people that are visiting for a weekend. They're kind of out taking the bikes out on the weekend. All right, very good. So that was our pandas implementation. So now let's do our polars. Implementation. All right, and what I'm going to do is I'm going to go up and copy our pandas implementation. And let's just recall how we've got that looking right now. So if I were to look at weekday ridership, we get a data frame that looks like this. So what we want to do with polars is see if we can't get something pretty much identical. All right, so I'm going to go back up, copy down the code that we used to do the analysis. All right, so this is what we had in pandas. I'm just going to comment that out, kind of use that as kind of a North Star as we go. All right, so we're going to do weekday ridership. And in this case, we're going to use data PL. And since we want to just use this columns, I'll do a select on that data frame to just limit that to those columns. All right. Now what we need to do, we want to try to convert started at to a date time with polars. What we need to do is use with columns and their expression syntax. So I'm going to say PL call started at. And this is a string, so we can use polars string. So I'm going to look polars to date time. So polars has a to date time method. It's a string method. So you have an expression, you do .str and then to date time. And so we would do a to date time. Let's just run this. All right. Let's see if that is working. So let's do weekday ridership. Looks like that's working out just fine. Let's actually bring in, I'm going to stop right here. I'm going to kind of run things. This is not, there's going to be actually an error here later on. So I want us to demonstrate this. So let me restart and clear this. And for just the time being, I'm going to go up here. All right, let's read in all of our data. I think we just end up working with all of it. All right, so it's going to take us a minute to get it in. I'll try not to restart the kernel too many times. All right, so let's go back to our pandas implementation. Yeah, so we actually ended up with a problem right there. So we didn't see it because we had only read in a certain amount of our columns. All right, so let's look at what this problem is, right? So let's look. So it says, there is some errors. We get an error. It says, hey, I can't do this conversion right here. So I ran into an error when I was parsing a particular. I assumed it was this format, but I got a problem at position 3606346. All right, so right now, when I had that error, we've got weekday ridership. So it actually did the PD, data PD columns to keep. So let's look at weekday ridership. And in particular, I'm going to use iloc to isolate that position. So I'm going to say I want to read, let's do 40 through maybe 49. So just right around it. All right, and here's the issue. So it looks like in June of 2024, they changed the way that they report report the started at. So if you notice right here, so this is essentially year, month, day, hours, minutes, second. But then right here, they're kind of reporting this, fraction of a second. So that when it hits this .43, it says, hey, that doesn't look like everything we saw before. So I don't know how to parse that, right? Because we changed the format that was used in the middle of the data collection. All right, so how do we get around this? So what I'm actually going to do is I'm just going to strip that piece off. Okay, so I'm going to say started at, just to show you exactly what that's going to be. I'm going to say, well, let's take that started at column. All right, that's a string. We can see right here, there's those fractional parts, whereas they're not up here. And then I'll do a string dot split. Takes it a second. So you can see right here, we've got that fractional part off, right? And then that regular date that matches. I'm going to expand that. So there's an expand option in string split, which will return that back as a data frame. So you can see up here, here's the first part, and then if there is a second part, it'll be in this column. So here's those things that need to be cut off. Well, since this is a data frame, I just want to grab the 0th column. Right, now everything looks good, so I'm going to use that to overwrite weekday ridership started at. All right, so let's go back up to our pandas code. And right before we do that date time conversion, we'll put that right in front of it. So now we run it. Takes a little bit longer because we're using more data. All right, we still see those patterns continue to hold, right? But we didn't get those errors. So now we're working with all the data. And now let's see what happens with polars. All right, so if we try to do that date time conversion, look at polars just seemingly handling it. Right. Yeah, and you can see, so it is doing it. It's converted it to a date time, but it's just saying, hey, well, some of them have those seconds, those extra seconds. So in pandas, we did see that it had a little bit of a problem. In polars, we're not actually getting that problem. We do have a proper date time column here. So just note that that is the case. Right. Now, again, it could be that, you run into problems here in a future version, but yeah, again, you just kind of got to, if you're seeing what those errors are, you can kind of hopefully isolate those and then get that converted. All right, so good. So we've got a date time. So now I'm going to say with columns. All right, now I'm going to take started at, now that that's a date time, and we do have in polars. So if I'm back on the documentation, this is where we found that string to date time. This is under the expressions area in the sections. So if you go to expressions, and there's a section called temporal, these are the things we can do that have a date time, so DT, right? And what they have is I believe it is weekday. Yeah, so we have a weekday. So we can do dt.weekday, and what it's going to do is it's going to return an integer, so a number, where Monday is equal to 1 and Sunday is equal to 7, and that matches that mapper that we had at the beginning. All right, so I'm going to say dt.weekday. All right, and let's call this is going to be our start day int. So an integer representation of that. All right, so we're almost getting done. So if we got this weekday ridership now, we've got this extra column called start day int. What I want to do is replace these values or create a new column where the value in the column is based on what this integer is in this dictionary. So if we see a 2 in that column, we want to replace that with Tuesday. All right. And the interesting thing is this, right? So if we think about our dictionary up at the top, well, it's mapping integers to strings, right? And if we look at that polars column, that's an integer column. So those are integer values, right? So if we do this, right? Let's say that we take that start day int column that was just created, and then we do a dot replace, right? And we give it our mapper. We call that day order. All right. I believe this is going to give us an error. Boom. Right. And the reason is it's saying, hey, well, you're trying to create things, you're converting from string to int, and that's failing because that column is already an integer. Let's see if we just rename the column, if that makes it better. So right now it's trying to replace the values in that column, right? So start day int is saying, hey, we want to replace those with essentially the values in that dictionary based on the keys that match. And it's saying I can't do that because that column's an integer and you're trying to replace it with a string. So it doesn't change that type. All right, let's see if we make it a new column and say maybe that will take care of that. Nope, it still doesn't want to do it. All right. And the reason is it doesn't know, because by default, when you do that dot replace in polars, if there are values that don't map, it's going to keep the original value. So what you need to do actually is do a replace strict. Okay. And we can just kind of look that up. So we'll do a polars replace strict. All right, so this will replace all values, right? So the key thing is if we do a polars replace, it replaces values by different values of the same data type, okay? And, you know, if values don't map, they're going to be set to some default value, and the default is it just keeps the original. So again, replace strict is ultimately in this 1.0 release, what you want to do is say, hey, I'm going to replace every value. And I don't know if, let's look one more time, if we do a replace strict. All right, it replaces all. So default values are going to be, if no default, an error is raised if any are not replaced. So it's going to be strict. If something doesn't map, it's going to give you an error. All right, but all of ours mapped. Great. So now we just need to do our grouping. So I'm just going to comment that out because the transition from polars or pandas to polars is pretty simple. So group by, 2 words separated by an underscore. When we do .ag, instead of this tuple expression, we need to do a polars expression. So PL call, write ID, dot in underscore unique. All right, we don't have an index in polars, so there's no reset index. And then we do have a pivot, but instead of columns, it's called on. All right, so at this point, we're getting pretty close to that data frame. What we need to do is divide by those column sums. All right, so to do that, we do a with columns. And what I'm going to do is I'm going to say PL all, so do this for all columns except for, all right, the column I don't want to do this for is start day name. So I'm going to take every one of those columns except for start day name and then divide them by the sum. There we go. There's our proportions. All right. Then I'm going to write that thing out to a pandas data frame. I'm going to set the index to start day name. All right, so we're looking pretty close to what we had originally. And then we had done that .loc on those values. So let me move that down. Great. So that should be it. Let's go see if we can generate our plot now, because we've named everything the same. It should be as simple as copy and paste. And there we go. All right, so there's your polars implementation. I'm going to go back up to pandas. I'm just going to put a time in front of this. That's still running. All right, so that took 6 seconds. And then for polars, we would do a time, and it took 546 milliseconds. So this is going to be 546 divided by 6.3, so 6,300 milliseconds. So it only takes 8% of the time to do that same sequence of operations using polars. All right, so that answers question 1. Let's move to question 2. All right, so how does time of day ridership vary by member type? So let's bring that question down so that we can see it. And then let's do our pandas. Implementation. All right, so in this case, we were looking at, day of week, day name, and now we're going to look at time of day, ridership, varied by member type. So it's actually going to be a very similar type of analysis. So what I'm going to do for pandas, I'm going to go up here and see if we can just modify the code that we have. All right. So in this case, I think the columns are going to be appropriate. So ride ID started at member casual. The thing that is going to change is right here. So we did that conversion to a date time. That still it holds. But instead of taking the day name, what we want to do is I'm going to say this is going to be, and let's change our data frame name as we go so we don't overwrite things. So first off, instead of the day name, all we want is we want to get the hour of the day. So in pandas, instead of day name, when we've got a datetime column, we can just say the hour. And I'm just going to change this everywhere I say weekday. We'll just go to hourly ridership. All right, so I'm going to go through and make all of those changes a lot of times. And this is another nice little benefit now that I'm doing this of polars, because again, we can just kind of chain all of those things together in that functional method. So I took that loc off as well because we're not going to be sorting by those day names, right? Because we're going to be doing hours. All right, so let's think through this. So we got our columns. We create this hourly ridership. We do a date time conversion in these two lines. And then what we're going to do is we're going to get, instead of start day name, we're going to call that start hour. All right, and what we'll do is group on member casual and start hour, get unique rides, and then we will pivot that where the index is the starting hour. And then everything else will fall the same. This will actually work out to be exactly the same. Let's look at how that looks. Perfect. Instead of this title being day of week, we'll just call that hour of day. And rider type. So in this case, we were able to pretty much use the same analysis. Only thing we had to do, we changed the name of the data frame that we were working from, kind of that temporary structure. We changed that from day name to hour. And then we just had to update our variable names or our column names throughout. Right? So this is, again, kind of, supporting what we had believed earlier, where we said, well, maybe, casual people or people just kind of visiting, whereas the members are the people that are, they're working and they're using this to commute. And what really kind of shows me that is if you look between the hours of, say, 7 and 9, right, you see a big jump in the percentage of member rides. And we also see a big jump in around like hours 16 through 18. Which we also see a big jump with casual, so that one's not as defining, but it's really that 7, 8, and 9, those hours when it's jumping. So that's probably when those people might be using the bikes to commute to work, and then that later peak is when they're using it to commute home from work. All right, so if we're thinking about timing, that took about 5.57 seconds. That was pretty straightforward, and then hopefully our polars will be as well. So I'm just going to copy that previous polars implementation. I'll make us a new markdown cell. This will be our polars implementation. We'll copy that in. And again, here, all we got to do is change it one time. So hourly ridership. Okay, so we're selecting our columns. We're doing that to date time conversion. Instead of start day int, we don't even need that anymore. We'll just say start hour. Is that what we called it before? Let me just double check. So start hour is what we called it in our pandas implementation. So we'll just say start hour is equal to, in this case, we don't have start day int. We're going to take that started at, which should be a date time. And since it's a date time, we can use those temporal accessors. And then in polars, hour is a method. Everything I think is actually a method. You don't have this whole juggling back between attributes and methods. You always call them with parentheses. It will group by member start hour, and then we just need to change start day name to start hour everywhere we see it, and then take that loc off. All right, let's take a look at this. Let's see, I do need to change my hourly ridership here. All right, now one thing that polars does when it's doing those group bys and returns, it's not doing a sort, which pandas does in fact do. So you can see that the hours are kind of jumbled up. So what we will put at the very end right here, before we do that to pandas, I'm going to do a sort by start hour. And there's our visual, right? So we see that same peak or, spike for member riders between 7 and 9, and then also between 6 and 18. All right, so that one was pretty straightforward. We were able to copy and paste most of the code from the first question. So let's look now at question number 3. Let me jot down something here. All right, so now we're going to go to question number 3. So let's go up and grab that. All right, so question number 3. How does ridership vary over the year by member type? All right, so I'm going to change that to Markdown. Very good. Let's look at our pandas implementation. All right, and let's see what we can borrow from before. So I'm going to copy that previous pandas implementation, and let's just think through this. So what we're trying to do is look at how does ridership vary over the year. So think about, we almost want to construct a time series by member type. So for each day, how many unique rides are there? And then look at how that's varying over the year. All right, so what we're going to do first, we're going to change this. This will be our daily ridership. So we'll get those columns to keep. We're going to continue to do this date time conversion. All right, and instead of, so we'll get that, let's look to date time. That's fine, that gets that there. And then what we will do, instead of getting the hour, we'll say start date. All right, and pandas has a method called dt.date. Again, that is actually an attribute. The weird thing is this will actually return a string. So just to show you that, let me comment all of that. And when that runs, it takes it a minute. When I do, oh, this actually gives us an error. Let's see what we've got. So started at, so we've got daily ridership here. And in our columns to keep, so data PD, daily ridership is going to be equal to that. And then I forgot to change that 1 hourly ridership. So let's let that run. And now if I look at daily ridership, it in fact gives us back something that looks like a date. But when I do a .info, that thing's actually an object. It's not a date time. So I actually need to do one more PD to datetime call to convert that to a datetime. So what I'm going to do is say, we'll take the value in start date and make that equal to PD to datetime that. Now when that runs, when I do that .info, start date is actually a datetime column. All right, and then it's very much kind of rinse and repeat. So you're kind of seeing a very similar process, right? We need to do some type of data cleaning, data prep, and then we can maybe do some type of group by aggregations. We're going to do a little bit more to this one in that group by, because what we're going to see, so it's going to be a little bit erratic. So let's do daily ridership is equal to that. We want to group by member casual, start date, get the unique ride IDs, and then we're going to pivot this where the index is the start date, columns are that, and the values are those number of rides. All right, we're not going to do any normalization there. We want to see the raw ride counts, but let me comment out this plot for now. All right, so we've got our time series, right? And you can see that there's quite big jumps, right? So from 7,000 to 3,900, back up to 7. So it's kind of really jumpy. And let's go ahead and work this plot out. Okay, so what if we were to plot this? So let me say I want to do daily ridership. I want to do this as a line plot this time, so we don't have an edge color. All right, and on the Y label, we're going to have just rides, and then we're going to have rides by rider type. And we no longer are going to be dealing with a percentage because we're not doing that normalization. And let's not rotate our ticks. All right, so let's take a look at this. All right, so you can see, you do see some patterns, right? But there's quite, there's a lot of jumpiness, right? Because there's cyclical patterns during the week. So we're seeing a lot of weekly seasonality that makes it harder to see that overall trend, right? There's a lot of variability, and you can see a lot of variability, particularly in the members. All right, so we're working with this data frame right here, daily ridership. So what if we wanted to smooth those out? So smooth out some of that variation. Well, what we can do is we can, instead of just plotting the raw values for each day, we can then apply essentially a rolling average, like on a 7-day rolling window, to kind of smooth that out. Right? And how would you do that? Well, if you grab one of those columns, right, on a pandas numeric column, you can call .rolling, and you can give it an interval, say 10 days. Right? It says, okay, well, I've got this rolling window of 10. And then what you can do is call one of your mathematical functions on that to compute a rolling mean. Now, for the first day in our data set, right, so we're doing a 10-day rolling mean. Well, for the first entry, you're not going to have 10 days worth of data, so it replaces it with missing values. And if I actually look at the first 12, you'll see it does that up until it can get 10 previous entries. So on the 10th day, we can actually compute a 10-day rolling window, and that's when we get the first value. All right, but what we're going to do is I'm just going to take that code, and right at the end, I'm going to overwrite the values in that column. All right, and so it was casual and member. And there we go. All right, so you can see during the warmer time of the year, so again, we are looking at Boston, right? So in the warmer part of the year, there's a high degree of ridership, both casual and members, but we see a decline during the winter months, especially around January, around the holidays, right? A lot of people might have time off work or using time off work. And then as we go into the year, right, we see a buildup all the way till we get back to those warmer months. All right, so that is our pandas implementation. Let's see if we can do this in polars. Fantastic. All right, and again, I am going to work from, let's go up to one of our previous polars implementations. So let's bring this down. All right, so what do we call that? Daily ridership. So let's say daily ridership right here. Same columns. So we're going to convert that to a date time. And then what we are actually going to do is we are going to get a, what do we call that? We call it the start date. So right here, we read in our columns to keep. We're just selecting those. We do the date time conversion. And then instead of getting a start hour, we're going to get a start date. And that is just dt.date, open close parentheses. We're going to group by member casual and start date. All right, when we do our pivot, we're going to pivot that where the index is the start date. All right, and in this case, we need to do that rolling. So let's cut this off the bottom. Let's see where we're at this point. So we've got daily ridership. All right, and in polars, if we are going to do this rolling, the thing is we've got to recognize that polars doesn't do this sorting. So let's just see if we could do, polars rolling. All right, so notice right here, here's our documentation. This is a data frame method. All right, so you give it essentially an index column and some type of a period, but you call this on the data frame .rolling. All right, and let's just look at some of their examples. All right, so df.rolling, so the index column is some, dt or a date time column as shown down in this data frame here. And then you can give it a period like 2d for 2 days. All right, so I'm just going to copy this from the documentation to help me out a little bit. But you call this rolling, and then you do a .ag at the end of it. All right, so let's do a .rolling. Let's say we've got an index column. Let's say it's going to be our start date. Let me make those single quotes. And we did a 10-day when we were doing pandas, so 10D. All right. No errors. And then I can do maybe a .ag. And what I want to say is say, well, PL all. I want to do this for all columns, excluding start date. Now let's just see if we can do a mean. All right, now we get an error. It says, hey, the argument in operation rolling is not sorted. You need to sort the expression first. So what polars is saying, right, if we look at this daily ridership, it's saying, hey, you're trying to do a rolling computation over this start date, but I can tell that that thing's not sorted. So it's going to force you to sort that first. So what we actually need to do is do a daily ridership.sort a start date. And you might say, well, why doesn't polars do it for me? I think polars is, kind of the ethos is it's forcing you to understand your data. So it's going to tell you what you need to do, make sure that that's what you want to do, and then you're going to have to implement that. But once we do that sort, everything seems to work. One thing to note is that polars, one thing that it differs with pandas, notice that we do get values back for those first days. So even if you don't have 10 entries, it'll just give you the mean of what you've got up to that point, right? So this is just the mean for the first day, the mean for the first 2 days, first 3. And then once you get 10, it will start computing that based on that true 10 days. So pandas, if it doesn't have enough days, it just gives you back missing values. In polars, it will give you essentially the mean up to what you have. All right, so now we can do daily ridership. We should have that average. And what we're going to do to get it to a pandas state, we'll do a 2 pandas, and then I'm going to set the index to be start date. All right, that's what that'll look like. So I'm going to pop that little piece right at the end. Nice, and we should now be able to copy our plotting right there at the end. And you can notice here at the beginning, right, we have values going all the way back, right? So that peak going up, and notice how it's kind of climbing. And when we look up here, you don't see that. And that's, again, because of those differences. And notice that it colored them differently, again, because it's sorted, but you still, in this case, the blue corresponds to the members. All right, so that took 6.78 seconds with pandas. Let's look at what it takes with polars. So 516 milliseconds, so more than 10x speed up on polars. All right, so let's look at our final question here. So let me just jot down timing to go back and put in chapters. All right, so let's look at question 4. So I'm scrolling way up to the top. And then question 4, how does ride time vary by member type and bike type? All right, so let's copy our question right here. All right, so what we're wanting to look at in this question is what is the duration of the ride? So we have a started at and an ended at column. So how does the length of time that they actually are riding vary by member and bike type? So do members tend to ride longer or shorter than casual riders? And does that change by different bikes? All right, so let's start with something we've already got. No need to build it all from scratch. All right, so in this case, we've got a started at, but if I look at that data pd.head, we also have the ending time. Okay, so we're going to get that ended at column as well. All right, and so we're going to do that daily ridership, or let's say, what do we want to name? Let's say this is going to be ride time comparison. All right, so that's going to be our columns to keep. Just go through and convert all of that, even though we might get rid of some of this. All right, so we're going to do that conversion to a date time for started at. We're also going to do that for the ended at time. All right, so we've got that for the ended at and started at. All right, so when we run this, we've got this ride time comparison. All right, we've got hopefully got date times for both started and ended at, and we do. And what we're going to do is we're going to take the ended at, and then we will subtract out the started at to get a duration. All right. And then there's a couple ways that we could do this. I think you can get dt.total seconds. I think, whoops, dt dot. You can get the number of seconds there, and we could divide that by 60. Let's look at this in minutes. So we'll just do this by 60. And this is actually the method I'll use in the notebook that is posted. I did show you how to do this with a PD time delta. But just to show a little bit of variation, we can say, well, give me the total seconds and then divide that by 60. And then that's going to be your minutes. So I'll say ride time comparison. This will be our ride time. Okay. We'll put that up there with the rest of our code. All right, so we'll have this ride time comparison. So now we've got a data frame where we've got member casual, we got the ride time, and also we need to get in the rideable type. So we didn't have that in there, so we need to get that column. It's rideable type. So we put that in our columns to keep because we want to know how does ride time vary by member type and bike type. So now we've got rideable type, what the type of the member is, and the ride time. So at this point, we can then go to our normal. We got the data where we need it to be. And we'll say by member casual, by rideable type, .ag. We'll say this is going to be our mean ride time. we'll just take that ride time column here and we'll get the mean of it. Let's look in the aggregate. Awesome. So now we can do a reset index because it's giving us back a data frame with a multi-index. So I can reset that index. And then we can do a pivot. Let's put the writable type on the columns. So I can say, well, let's pivot that. Let's say my index is going to be member casual, whatever's in that column. My columns will be my writable type. And the values will be the mean ride time. All right, that looks decent. So let's put this up here. All right. Really takes these a while to run. Thinking it's 7 seconds. All right, I'm just going to copy some stuff from the plot above. We're going to have to change a lot of stuff. We're going to visualize this using a heat map. So I'm going to make a subplot, and I'm not going to be able to use pandas plot anymore. But in this case, we've got this ride time comparison. We've got casual and member in the index, and the different types of bikes as columns, and then values in the cells. And in this is a perfect case, we can use a heat map from Seaborn. So how do we do that? Well, we would do sns.heatmap. We can give it that data as long as it's in that structure. So it's going to take whatever's in the index. That's going to be the rows in the heat map, and whatever's in the columns will be the columns. I like to do a cool, warm color map. We'll say the minimum value is going to be 0, right? Because otherwise it's just going to set it to the smallest value it sees. But actually, in this case, there could be a ride duration of 0, so, or a mean ride time of 0. So I'm going to force it to say that. I want to have annotations. I want to see the values in the heat map. And I want to format those as a floating point number with 2 decimal points. That's what that does. I don't want a color bar. Let's put some lines between the cells. We can do with line width. And then I'm going to say line color is equal to K. Kind of give it a little bit of good differentiation. And then what we would do, we'll take off that legend, take off those spines. We won't have spines here. I'm going to set both the X and the Y label to nothing. And then I'm going to say that this is going to be the mean ride duration by member and rideable type. Let's see if that is working. All right, so that looks decent, right? We can go with that. So in this case, what we do see is that, you know, in general, your members tend to have shorter mean ride durations, right? Again, they're going to work. They're on a mission. Versus your casual, and it tends to be that it takes longer for people on classic bikes than electric bikes. Interestingly, you've got that docked bike category. I don't know if that means that maybe a user is still renting the bike, but maybe they've went in somewhere like a museum in the case of a casual rider, or a store in the case of a member. So, but we do have that docked bike category. And we can definitely see that the casual riders, that tends to be the highest ride duration, right? And it also could be that the casual members don't know how to end a ride. I've seen that in some other ride sharing data sets where if you've ever used a ride sharing system, sometimes when you're done, you have to dock it in a certain way and take a picture for that to end. And maybe they just don't know how to do that because they're not members. They're not as familiar with riding these bikes. They're visiting. And maybe it just counts as a docked bike ride. All right, let's see how we can do this with polars. So I'm going to go up, copy some polars code that we had from before. will have to change quite a bit. All right, so this is going to be our polars implementation. There we go. All right, so we needed to get into that and then writable type. That's columns. All right, let's just look. So we're going through, we get the columns that we want. We do convert started to a date time. I'm going to copy that piece. And then I'm also going to convert into that to a date time. And then I'll do another with columns. All right, I'm going to say this is going to be our ride time. And that's going to be PL call ended at minus PL call started at. Yeah. All right, for now, let's just see what that looks like. So let me comment everything out below. That runs really, really quick. If we look at daily ridership, which we need to rename that, we see that we get something, some type of a duration. All right, so let's go to Panda's documentation. So I'm still in this expressions area under temporal. If I look through, they've got a total seconds. And it says extracts the total seconds from a duration type. So it looks like this is perfect. All right. So let me go back and rename that, like I'd call that ride time comparison. All right. And what I'm going to do is I'm going to say, well, take that difference, because we saw when we ran that gives us back a duration. And immediately on that, call DT dot total seconds, and then divide that by 60. And let's see, did that actually store that? All right, so that's still a duration, so that's not what I was looking for yet. Let's just run that one more time, make sure. So we're still getting ride time as a duration. Let me just double check this right here. I think what I've got to do is put an additional set of braces and say, go ahead and do all of that conversion to seconds first. Let's see, still not working out as I would have expected that to. So let's see, PO call ended at. So that's that first expression. Let's just do this one at a time instead of trying to put this all in there at once. All right, so I'm taking ended at, which is a date time, subtracting started at, which is a date time. All right, and then this should give me that expressed as total seconds. And it is not doing that for me. Interesting. All right, so let's just double check one more time. So ride time comparison, I've got with columns, ended at, should be a date time. PL call ended at, started at. We've got the ride time there. And then we do the DT. Let's just look at that delta. That should be fine. No, it's because I'm calling daily ridership. I changed the name to ride time comparison. It's been a long video, right? So there's our duration. Now I should be able to wrap that all around, say do all of that, get the total seconds. It's got to be the dot DT total seconds. There we go. Now we have seconds. And now I can divide that by 60. And that converts me to minutes. Awesome. Sorry for my little little challenging situation there. And instead of doing the group by from pandas, or what we had that last time we used polars, let's go up to pandas. So right now we've got that conversion in place. Let me go up and see what we did with pandas. So after we had done that DT conversion, we did this group by and pivot. So this was our pandas code. If we're converting that to polars, group by is group underscore by. We're going to do member casual writable type. Mean ride time is going to be ride time mean. And then we don't have an index, so we can't reset the index. And when we do a dot pivot, we need to do the index as member casual, and it doesn't have a columns argument. It has an on argument. All right. So now ride time comparison looks like this. Something is wrong here. So we're looking at electric bike, and we've got this list. So, oh, it's because in pandas, this is how you do the aggregation. In polars, we have to do an expression. So PL call ride time dot mean. Now we're getting there. So we do a two pandas. And then we can do a set index. We want that to be the index. So I'll say that. And we should now look just like we expect with our polars data or our pandas data frame. So now I can go up. Copy our plot. And there we go. So 372 milliseconds run. You can see again the sorting, because polars is returning things in a different order. It's not doing that sort by default. But we see the same trends, right? So in general, members on both bike types tend to be, significantly quicker. They're on a mission. And then we do have that really high docked bike occurrence. It took 372 milliseconds for polars, 7.52 seconds. So if we're thinking about a speed up, so it takes 372 with polars versus 520 milliseconds. So it takes polars less than 5% of the time it took pandas. All right, so I'm going to just do a real quick restart, clear all outputs. And let's go through and run everything one more time from start to begin. We're beginning to end, just to make sure everything's good. So it takes us a second to load all of that data from zip files, which I would encourage you. The reason I really wanted to show you this is a lot of times, it might seem a little bit inconvenient, but certainly if you can figure out the way to just read it from its raw format, then you don't have this intermediate step of, oh, I've got to uncompress these things. What if it's a file you get every day? You don't want to do that. Plus, if you do get compressed files back, they're going to be a lot smaller to store on your machine, so you can save some hard disk space. So if you can figure out, Python's a beautiful language. There's a lot of utilities to work with compressed folders. So if you put in a little bit of effort, figure that out, you don't have to do that extra step. Plus you save storage space. So here was our day of week ridership. So members are more kind of during the week, and then casual riders tend to have a spike on the weekends. Here's our hour of day. So members during that kind of morning rush and evening rush. If we look at ridership over the year, we definitely see a strong effect of the colder months, reducing it from peaks of over 10,000 rides per day on average to less, or, roughly 2,000, right? So huge changes in ridership. And then as far as ride times, we definitely see that members tend to be much more quick on their rides. It's a much shorter experience, whereas a casual person might be visiting the city and just kind of taking their time. In all cases, we see that for this particular analysis, polars offer significant speed ups in comparison to pandas. And hopefully, again, this video, along with the other video that was previously posted looking at some Netflix titles, has really kind of, helped you see, at least kind of the ethos of, okay, if I've got pandas code and I need to translate it to polars, how do I do that? This kind of functional format. We've also looked at a little bit of documentation. I think polars documentation is laid out relatively well. Of course, all documentation takes some getting used to. But I do think that it is pretty amenable for being able to get up and help people get running with it pretty quickly. All right, so that is going to be the end of this video.